Hey guys, so we got another auger, typical maintenance type stuff on it. This one here's got a worn out pocket because they let that tooth wear or smear off, break off or so. That's not a big deal. These are though create a bit of a problem because you cannot access the back of here. And I suggested cutting holes here to access being able to punch them out from the back, but they don't want to do that. So they use the other type of hammer, get that, or a J hook type tool to get them out. But I thought I'd show you guys a way to cut these out with a torch, or maybe even with an exothermic, without having to remove this pocket from where it's at, just so that they can, it's a little bit less work, and show you guys something. So these are really in there because they probably had that drilling mud, that slurry stuff, and that works its way in there, and man, it concretes in there after time if you don't change them out too often. A lot of times drillers use regular bearing grease, and they'll stuff it, they'll put it all over the tooth, hammer it in there to keep some of that out. But once you don't change them out in a long time, that grease wears itself out, works itself out, I should say, and then it just fills with mud. So stay tuned, and it's a nice little project. Just thought I'd show you something. Should be short and simple, so shouldn't take too long. All right. Okay, so now that I got that cleaned up, what I'm going to attempt to do is cut this flush that way. Now I know, and I know that you know, that these have a taper in them, so they kind of sit in there like a seat, almost like a valve on a engine head. But there's another little trick to get around that. So let me cut these off flush first, and I'll show you how to get around that taper. Okay, so this last one didn't come out so pretty at all because it broke and had some jagged edges, had a bunch of dirt in it. And so once I cut those flush, now what we can do is try and get that taper out of it, the little tapered cone piece. And what you do there, you just turn down your oxygen, that way it doesn't blow through the parent metal, which is that pocket. And turn it down about 15-20 pounds. So when you melt this edge and you press the oxygen lever, it just kind of oozes that stuff out of there. And that way you can either start knocking the tooth in the backwards direction or free it up to where you can at least pierce through the center of it. So give that a shot. Let me turn the pressure down. Need to put a piece of metal down here because it's gonna crack my concrete. All right, so now a little bit of a preheat here on the sides. I'm gonna let some oil soak in there and see if I can knock it backwards and then just cut the head off of the back side. Now I don't know that this will work, but it sometimes works, especially if they haven't been in there too long. But it's always a guessing game. And so if this doesn't work, we got another option to try. I do like though that smoke is coming out of that pocket there though, so maybe some grease is finally heating up. So we'll see. Let me clean it up. Okay, as you can see, I got some of the taper out of there, and I tried hammering on them a little bit. I didn't try hard enough. I could have tried harder, but let me try and dig a little deeper and try and see if I can hollow them out and really get this whole area hot to where the pieces swell enough to break the dirt free from between the two pieces. So let me try that again. Now you may be wondering, why don't he just cut them off and put new ones on? Now, while that's normally the case, the customer only has 2 pockets on them right now, and sometimes you're out in the field and you just need to, fix what you got. So I'm trying to show you guys, and because yeah, I could have taken them off and put them on a lot faster than that, but it's at least hopefully a learning experience, something you can pick up some pointers on. So let me clean that up and see if I can't knock them through. I was able to dig in there fairly deep, and usually that will work them out once you start hammering on them, but not this time. So no more time for Mr. Nice Guy. So instead of, I'm still going to leave those pockets there, but instead of using the torch to hollow them out, I'm going to use my fancy tool, Exothermic Slice Torch. This guy's pretty good. I don't know if you guys seen any of these, but these are nice. So what this will do is help me pierce right through the center of that guy, right in there. And I'll hollow it out, and then I'll be able to knock it through. So this is gonna be fun. I don't know if you guys seen it, but I think you guys would enjoy it. All right, okay. So this process here only needs an arc source, which I hooked it up to my welding leads. And normally they come, or they suggest a 12-volt battery, because you just need to scratch start this rod. Once it's in the holder, it's almost like a car wash handle. And as you press the lever, oxygen actually comes out of that. And so in my case, in this case here I should say, it's set at 80 pounds. And so 80 pounds of pressure will be coming out of these little folded holes right in here. And I don't know exactly what's in there, maybe some type of, I don't know exactly what's in here, but once the oxygen is flowing and you scratch start the arc, it'll continue so long as you still have oxygen flowing. And so it'll be like a fireworks sparkler. And as you press the oxygen pressure will be coming out of here and melting everything in its path. So I will be using this welding lead as my scratch start, and I will strike it on there and it'll start it, keep the oxygen flowing, and then press it into that opening there, and it should pierce it rather quickly. It's a really neat process, really fast process. You use that for getting stuck pins out of rusted maybe pivot points on some machinery that doesn't get used a lot or replaced a lot. This is the perfect tool for that. So I figured I'd show you guys this same thing. All right, let's give it a shot. Of course, the battery died when I gave her the onions, like Derek says, but it's really fast process. And let me show you here. I was able to pierce it right through the center, and so that should be able to free it up enough to knock through now. And if not, I'll just hollow it out some more. But let's give it a shot. Let me speed up the time warp and knock it out. A lot of hammering. I'm out of breath. So anyway, I was able to push those through, but now the tails are sticking out the back, which is not a problem. I'll just reach in there, trusty old gas axe, cut them off, and continue pushing them through. So pretty simple. All right. I got them out without damaging the bores. This guy did cut a little bit. This guy is a little bit wore down, but I may just build that up with a stick welder. So now it's the process of just cutting those off and putting those on. It's not that hard. So I'll probably just fast forward through a lot of that because that's pretty simple replacement. So let me turn this thing upside down and see if I can't cut these off. real closely, you can see the parent metal, the separation between the weld, parent metal, and the pocket that I just cut out. I see a perimeter of weld there. There's a layer of dust in there that was keeping me from cutting with a torch, and this is actually still a piece of the pocket, the last one. So if you're real careful when you cut it, you can actually almost cut it exactly the way it was put in there. So a little more trimming, and the new pocket should just slide right in there. All right, here we go. Cleaned it up about as best I could. You can still see the parent metal back here, and then I put a little bit of a bevel there. Cleaned that weld off. That's pretty close right there. And then same thing over here. I did a little bevel on the bottom side as well, so hopefully it'll go back into place. And this is it right here. Yeah, right there. So there you go. I'll just match that same point, the height. I'll tack it up and I'll weld it out. And I'll do the same for the other side. So I may not bore you with that one. I'll just do this one here. All right. Man. Using MIG just to fill in the big gaps, and I think I may just stick weld over it just so it holds on a little bit better. And I could MIG it all the way out and hold fine, but either way, what do they say? 6 of one, half a dozen of the other. That'll work. I'll fill in that gap up there, and then just weld it up a little bit more. I'll fill this up a little bit better so it hangs on a little easier with the weld. And that's about it. Just keep trucking. All right, so I've got one side done. I'll get the other side done over there, and things are looking good. I get a lot of questions about short circuit MIG, and I guess if it's done right, it's just as strong as anything else. So I don't see why some folks have problems with it, which is fine. I guess it's still a good welding process. Some people like dual shield, some people like stick welding, and short circuit MIG is fine. Right now I'm actually running it very cool at 19.4 volts and 306 inches per minute, and I think it's 035 wire. I haven't looked, but either way, yeah, it is cool, but it allows me actually to weld slower, which in a sense is very similar to stick welding in that it'll preheat the pieces that I need. It'll preheat the parent metal and the pocket at a slower rate, which will prevent cracking sometimes. So it's very similar. Of course, nothing can beat stick welding for a situation like this, because stick welding has great elongation properties, especially with 7018s. So they're a very tough, flexible rod. But anyway, I'll put the other tooth on here. Pocket, I should say, sorry. Pocket on there. And I'll flip it over and weld the top side. We'll be done. Oh, sorry. No, actually, customer wants me to hard surface the outer perimeters here as well. So I might show you guys that, might not, who knows. All right. Now I flip this guy over. That was going vertical the other way, right? So I just have to weld in there, around the back there. Yeah, plenty hot. So that should be fine. Same thing here. A little bit of a gap, no big deal. Another little weld there. Small weld around that joint, around here. Looks good. Then I'll lay it on its side, wire brush this edge off, and put some hard surfacing on it. So, looking good. I didn't even measure how big this was. Like a 42 inch. 48 inch. 48 inch auger. Not bad. That's all right. Should hold till it breaks. Something back here. Get undercut? No, it's not undercut. Almost looks like it. Yeah, that should do it. Now lay this guy on his side and hard surface. All right. One of the things about hard surface rods is that they don't always mix. So here you see some older material, and when I add the material I'm going to add, sometimes they just don't jive, you know, and so you get a lot of porosity, a lot of yeah, just porosity, nasty stuff. And so you know, you just have to keep pushing through that. And sometimes it takes a couple layers. I think I have 1/8 inch rods. I should be probably using a bigger rod. That's all I got. I'm using a Studi number 35, which I believe is for metal to earth abrasion. So that does really good. Hadn't used them in a long time. And that's what we'll be putting on here. Now, some people like to do a zigzag pattern, which is good because the principle behind it is that as you have this zigzag, this little triangle here, dirt will trap itself in that little void and create a cushion for the dirt to slide right over. I like to do little zigzag, like squared off zigzags, and it takes a little bit more time, but it actually works pretty good because it traps more dirt between the vertical lines. And you always want you want the lines of the hard surface to be perpendicular to the travel of the wear. So this way, this way, this way. That way it creates little pockets and pads of dirt, and it'll slide right over. So that's the principle behind that. So that's next. If you look closely, you can see some has been done before. Now I like to use the brand Studi. Studi is pretty good. Number 35, I believe, is metal to earth application. And one of the things about hard surfacing rods is that sometimes they don't mix well together, different brands. So as I go over this and this zigzag pattern, they may create a lot of porosity because they just don't blend well. And I mean, that's just part of it. That's just the way it is. You know, and I'm not going to sit here and grind all that stuff off and start fresh. So, you know, a couple layers should be able to do it well. In some areas I'll do the zigzag to repeat what they have here. But I actually like doing square zigzags to create more of a square pocket to catch the dirt, so it slides over as a cushion. So it may change up here and there, but so long as it's got something, it'll keep it from wearing the edges of the auger out. So I'll show you some of the good and some of the bad, because I'm almost guaranteed that there's going to be some with some bad porosity that it just bubbles up horribly, and that's just part of it. So, all right, let's get after it. Well, I got it done. A lot of welding on hard surfacing. A little bit of a zigzag pattern. Came out alright. Nothing really pretty about it. I did put that on it just for kicks. But anyway, I replaced those two pockets there. One on there and one on the other side. I did 2 passes of 1/8 inch Studi number 35. And that's the other one right there. Not bad for wire. And you know, again, it's just something that you got to maintain. These things they take a lot of abuse. So I hope you guys enjoyed it. I mean, the hard surfacing welding is a little boring, right? But I mean, it is what it is. It's got to be done. But I thought I'd show you how it was to replace these guys and how to get these guys out. So again, thanks for watching, and we'll catch you guys on next one, because rain is coming. All right, see you guys.